Hello, this is Professor Gilman, and today we're going to talk about the lottery, okay? And so I'm going to do a problem that involves randomization, and I'm going to use this premise: how do I win the lottery? Okay? And so with all the talk about the Powerball jackpot, just want to let you know that today is January the 8th, 2016, and the Powerball is up to $800 million. I thought it would be a good idea to update my lottery simulation video with one that uses StatCrunch. Why? Well, there were some things I could have done better in the Excel video, some things that I learned from students. I no longer require the project, mostly, that's in the video, and so some students do it, and that makes me sad. And it's super easy in StatCrunch. There's a couple of hoops that you have to jump through in Excel, some minor programming, and it's just super easy in StatCrunch. So now we're going to simulate. We're not going to simulate the Powerball, okay? Although, oh no, undo. Although using this technique, you could scale it up to do that. You would need a much larger simulation, and you would get into some very interesting algebra, algorithms, formulas. It probably would end up being better in Excel at that point, but we're just going to start with something much more manageable and in the end much more generalizable to other problems that you might actually use this for. Okay? So, here's the story. Suppose your local lottery is only 10 digits. It's going to draw numbers 0 through 9, and it gets drawn every day. And so you read an article and it says, win the lottery using our proven method. And of course, you know, proven being capitalized means obviously this is true, right? So simply send $25 to this address and we'll send you the winning method based on math. Ooh, it's based on math, so obviously it's going to be true. All right, and we're going to talk about that. All right. So you think, wow, this is awesome. I'm going to be rich. So you send for it and a letter comes explaining the method. And it's actually a very short letter. It says, watch the lottery for a while and record the winning numbers. Then find the least frequent value and play it. It will show up more frequently to balance out the other numbers. Okay? And so let me put a caveat in here because if more than two values are least, just pick the lowest value. And that'll clear some things up as we're doing this. You don't have to do it this way, but just for a little bit of clarity, right? So it's a very short letter explaining this method. And you're like, wow, you think, I can totally do that. And so you start playing. And so we're going to ask some questions. Does it work out? Did you waste your money on this method, and why? And so to answer this problem, we're going to use StatCrunch. You can use Excel. I showed you how to do that in the other video. And so in StatCrunch, we're going to set up the lottery winning numbers by generating 40 values. Okay? Then we're just going to use that simple histogram tool to select the least frequent value. There is a way to compute it, but I think the histogram is just such an easy tool that seems like the best. Then we're going to run the lottery for 10 more simulations to see if we win more. Okay? Would I have won more by this method as opposed to something else? Then it's time to look for the least frequent value again and bet it. So what I'm going to do is I'm going to run the simulation, right? See if I win more, and then I'm going to run the simulation again. I'm going to look at those numbers from this simulation, right? To look for the least frequent value again, and then bet it. And so what we're going to do is we're going to repeat this a few times to see what happens using this method. And we do have to do it a few times because while we haven't talked about it, sample size is really important. And I will talk about that toward the end. Okay? So here's what we're going to do. Bam! Here is my StatCrunch, right? And it's completely blank. And so how do I start this simulation? Well, I need to simulate something, right? So it turns out that if you click on data, there is actually a simulate button, and it will actually simulate all different types of data, okay? Now, here's where you have to think, and I think most of yours are going to be like this logic, right? Every single value has an equal opportunity of coming up. The 0 has an equal opportunity of coming up. The 1 has an equal opportunity of coming up. And when everything has the same opportunity of coming up, that's a uniform distribution, okay? Now, this is uniform, and then we've got discrete uniform, all right? And so if you think about discrete uniform versus uniform, uniform is you can take on any value between 0 and 9, including like 2.5467, right? Discrete just means you can only get 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So it seems like discrete uniform is really what we want to simulate here, because this is going to give everybody the same chance. That's what uniform means. And it's going to be discrete, just those single integer values. All right? And so I'm going to click on discrete uniform. Now, the number of rows that I want is the number of times that I want to simulate drawing the lottery. And here I said 40. I'm going to draw it 40 times. But I only want that to be in column 1. So in one column, I'm going to draw 40 times. The parameters, see the parameters here, are the minimum value of 0 and the maximum value of 9. Okay? I could have done 1 to 10, but it seemed like single digits, much more generalizable. Good way to do it. It turns out that most of this stuff isn't going to make a difference. We could compute for each column the least frequent value, but again, then we start getting into like these formulas and Excel and stuff, and I really want to keep this straightforward. What do I want to call this column name? I want to call this winning, for the winning numbers. Okay? Seeding this, we're going to use a dynamic seed. It's randomly going to generate the number that it randomly starts from, which is kind of interesting. But yeah, we're going to use a dynamic seed here. That makes a lot of sense. You can use a fixed seed, but for each simulation, you probably want to change that fixed seed to some other value. And so I'm going to go ahead and use that dynamic seed, and I'm going to go ahead and click compute. And hopefully what you notice right away is that I've got this winning column, and I've got values 6, 4, 9, 2, 9, 0, 4, and I've got 40 of them that are discrete values between 0 and 9 in here. Now, I could certainly count up all of the 2s, all the 3s, all the 4s, all the 5s, but why? Why would I do that? I have a beautiful tool that I can use, the histogram, that will allow me to essentially count all of these numbers right away. And so what I'm going to do is I'm going to graph the histogram, the winning column. Now, I tried this a couple of times, so this is just to save you some time. You really do need to start at 0 and make the width 1. Otherwise, StatCrunch is going to default to a width of 2, and then we won't be able to count each of our individual numbers. I think this is really helpful. We haven't done this before, but if you put the value above the bar, then you don't have to kind of use your eyeball, and this makes things also a little bit easier, right? And so now all I have to do is click compute. And what I've got here is the actual frequency, right, of each value, 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9 across here. And so you're like, oh, look, the 3 showed up, right? This is 0, 1, 2. Oh, okay, so 2 showed up 7 times. 3 showed up 5. 4 showed up 4 times, right? But the least frequent values are going to be 1, right? The value between 1 and 2. So 1 showed up least frequently, 5, and it looks like 7, okay? Because this would be 8 and 9. So this is 7, okay? So going back to our directions, right? in StatCrunch, we set up the winning lottery numbers, 40 values, we did that. Then we used a histogram to select the least frequent value. And which least frequent value am I going to pick? Because I have 3 of them. Well, if more than 2 values are least, pick the lowest value. And that's going to really help us out here. So we have to make a few less decisions. So as I can see here, 1 is the least frequent value and the lowest value. So that would be what I would want to bet. Okay, I want to bet 1. Let's see how frequently it shows up. Okay, and so I'm going to click data, and I'm going to simulate again a discrete uniform distribution. And how many times am I going to play the number 1 to see how often it comes up, right? So let's go ahead and try it 10 times. All right, so we're going to try it 10 times in one column. And of course the minimum again is 0 and the maximum again is 9. And the prefix I'm going to do for this is bet 1, right? Because I'm going to bet the number 1 and see how many times it comes up. And so we plug it in, and look, I won 1 time. Well, if you think about it, right, the odds of 0 through 9 coming up, the odds are that it's going to come up 1 time in 10. I didn't actually win more often than I would have thought. In fact, if I go ahead and draw my histogram, it turns out that I probably would have been better off betting. Oh, here's one. I would have been better off betting 2, right? Or 5, or 7. Okay? Those would have been the better bets. And you thought, well, maybe you didn't give it long enough. Okay, all right, maybe I didn't. Maybe I didn't give it long enough. So let's go ahead and figure out what the least frequent value is now. All right, let's go ahead and take these winners. We're going to go ahead and cut those from bet number 1. And I'm going to scroll down and I'm going to put those at the bottom because those were the next 10 winners, right? And so now I'm going to go look at my histogram and see what's the least frequent value that keeps showing up that's got to be like due. So here we go, compute. Oh, look, it's still the value 1, and it is definitely the least frequent value, all right? So now, instead of doing it once, I'm going to go ahead and simulate my discrete uniform, and I'm going to bet it 20 times, okay? And hopefully I will win more than twice, all right? So, why do I want to win more than twice? Okay, well, basically data, right? Compute, expression. If you have 1 out of 10 numbers, that's going to come up 10% of the time. And if a number comes up 10% of the time, right, and you pick it 20 times, then you should end up with 2 values. So this is what I would expect. I would expect the 1 to show up twice in these 20 values, right? And so it really needs to show up more than twice to be better. So here's my second bet. So I'm going to graph in the histogram this bet right here. I'm going to go ahead and start at 0 and go by 1s and put my value above the bar, right? And compute. And I can see, wait, there aren't actually any 1s here. The 1 didn't show up at all. In fact, I would have been much better off betting either 0 or 5. 0 or 5 would have been above, and then of course the most, right? The best bets, and then of course 6 and 9 were above average. Wait a minute, those weren't the least frequent values. Those values showed up a bunch earlier. what's going on? Well, I can't really, and I'm going to get rid of these columns right here because they're, oh wait, just this one and this one, right? So let's run the simulation a few times. Maybe this was just a fluke, right? And so now I can still see that 1 is still the least frequent value, so I'm going to simulate my discrete uniform distribution. I'm going to go ahead and do it 20 times again, right? I'm going to go from 0 to 9, and again, I'm going to go ahead and bet 1, but this is actually the third time that I'm going to do it. Again, I'm using that dynamic seed. I'm going to click compute, and there it is. And you'll notice that 1 doesn't come up at all. Really losing money on this scheme. And because 1 hasn't come up at all, it's still got to be the least frequent value. So let's go ahead and simulate again. And we're going to get that discrete uniform. And let's go ahead and do it 20 times again. And I'm going to go from 0 to 9. And again, I'm going to go ahead. Oh, so this is kind of fun, right? So let's... No. I was getting ready to do something, but let's not do that. Okay. Bet 1 again, right? And so I'm going to click compute. And there's my bet 1 again. And look, it comes up 1, 2, 3 times. So this time it actually came up 3 times, and I actually went above what I would have expected. I would have expected 2, but I actually got a third one, right? So I got 3 ones, okay? But this is after 60 plays. So really I'm still in the hole, okay? That kind of stinks. Let's do it a couple more times, right? We should really run this a few more times. Let's give this the benefit of the doubt. Oh, and here's what I'd like to do. Let's figure out what the least frequent value is now. We got this graph of 20, so let's go ahead and do the histogram. We're going to do this last one. We're going to start at 0, go to 1. I'm going to put the value above the bar, right? Because now our 1 finally paid off. Now I'm going to go ahead and compute. The least frequent value now is 5. The lowest value and the least frequent value is 5. So now what I want to do is I want to bet 5. So let's go ahead and simulate with my discrete uniform. 0. Oh, wait. Let's do 20 times. We're only going to run 1 simulation from 0 to 9. And now we're going to bet 5. Here's my bet 5. Right? And so I'm going to compute. And again, I would like to see it 3 or more times. So there's 1, 2, 3. Okay, so that was good. So this one I won 0 times. This one I won 0 times. This one I did win 3 times. This one I did win 3 times. Okay, so you're like, oh, maybe there's something to this. And this is why you want to run it several times. Now, I want you to notice the average of 0 plus 0 is 0. 0 plus 3 is 3. 3 plus 3 is 6. If you take 6 and you divide it by 4, you're not doing very well. That means you're winning 1.5 times when you, on average, should win about 2. Okay, so we're not at our expected value yet. This is making us very sad. But again, let's go ahead and graph our histogram with our bet of 5. Let's go ahead and start at 0 and go to 1. Put the value above the bar, right? And just look at what happened. And oh, look, 0. Let's bet the 0, you know? And I'll bet the 0 has been pretty neglected value, right? So let's bet the 0. We don't want to bet the 1, right? Looks like 4 would have been our best bet. That would have been awesome, right? That came up a lot of times. But 4 has been coming up, right? That was never been a least frequent value. So that's kind of interesting. Let's go ahead and hit data. Let's go ahead and simulate our discrete distribution. We're going to do 20 times again, 1 simulation from 0 to 9, but now we're going to bet 0. And I click compute, and it looks like the 0 comes up once, twice, and that's it. So that's twice. that it comes up. So this is not looking really good, you know. So I've done it 1, 2, 3, 4, 5 times. So let's go ahead and compute what the average is for that. I had a 0, a 0, a 3, a 3, and a 2. And of those 5 values, that means I win an average of 1.6 times. What would I have won on average just betting any random number? About twice out of every 20 plays. So that's kind of interesting. Now we could do this several more times, and we're going to start to see that it's going to bounce up and down between about 0 and 4. Occasionally we'll get a 5 or a 6. That would make us super happy. But really it's going to bounce around between about 0 and 4. And you're not going to see much outside of that range just because of the randomness, right? So here we go. So here's the end of the video. What did we learn from our simulation? Well, for one thing, I hope that you saw that when choosing things at random, interesting things can happen occasionally. Like 6 4s coming out of 20 picks, right? But these things should only happen occasionally, okay? And over the long run, it should give you a real idea about what the answer is. And what we would have seen if we had run 5, 10, 15 more simulations is that this value of picking the least frequent number is going to get closer and closer to this number, which is the actual expected value when you're betting on 20 numbers, 20 lottery picks. Okay? And so this value is going to keep getting closer and closer to this value the more times that you run the simulation. So that's our answer. So this brings us to the last point. The gambler's paradox. Okay? This is actually the logic used to create this system. And to a certain extent, it is actually true. All right? The lowest number will eventually catch up, and the distribution will be uniform. Okay? That will eventually happen. However, in mathematics, eventually can be a really long time. Okay? We are talking an infinite number of lottery draws. And so, while the idea has some merit, it's not really a practical strategy when you can't really wait an infinite amount of time for a number to start balancing out that has been least frequent, right? This is why the Powerball is never going to be broken or have a system, because the number of drawings required to even start to get all of the values to show up would be thousands of years. And unless you're an immortal, you're not going to be living thousands of years playing the Powerball. And if you are going to be living for thousands of years, stop playing the Powerball. Okay, you're going to be doing something more productive with your life. And that makes us happy. All right? So, if you learn some of these things from this simulation, and you can use StatCrunch to do your own simulations, then that makes us happy. See you in the next video.